Okay, so we're going to finish up lesson 8.5 for Algebra 1. This is part 4. All we have to finish up is number 15 and 16 here. And so before we start, I want you to pause the video and read number 15, underline the things that are important, see what you can come up with, see what you would do before we actually start, and then push play so that you can see what's actually going on here. So hopefully you've already done that. You've pushed pause, you've underlined the things that are important. So right now we're talking about Penny, and we want to know her jump can be modeled by the equation that they gave us. And so we want to know where h is the height of the leap in inches at t seconds. Find the values of when t is equal to an h of 0. So we want to know that when the height is 0, what is our time? And so we have to look at this and we have to say negative 16t squared plus 20t. Well, what's in common with them? A 4. So we can pull out a 4, and we can also pull out a t. So what's in common is a 4t. So what times 4t is negative 16t squared, and that's negative 4t. And what times 4t is the positive 20t, and that would be positive 5. Then you set both of these equal to 0. So when we divide by 4, we get t is 0. And when we subtract 5, and then divide by negative 4, we get our t is equal to 5 over 4. So what this really means is that this is a quadratic problem. So Penny's jumping over a hurdle here. Her time of 0 is when she's at a height of 0. So it's when she's began. She hasn't even started yet. She's still at a height of 0. She jumps, and when she's at a height of 0 again, it's taken her 5 over 4 seconds, so which would be 1.25 seconds to get to this point here. Number 16, pause the video and read 16, underline the things that are important, and then we'll work it. So hopefully you've already done that. Same thing on A. We have a rocket that's launched straight up with an initial velocity of 125 feet per second. The height of the rocket in feet above sea level is modeled by the formula, and they tell us that. They wanted to know on A when h is equal to 0. So we plug in 0, and we look for what's in common between 125t minus 16t. And so let's just take out a t here, and so we have t 125 minus 16 t, and then you set each equal to 0. T is equal to 0, or t is equal to 1, or sorry, not, or 0 is equal to 125 minus 16t, and then you solve. So I would just add the 16t over, so it's 16t equals 125. And so we divide both sides by 16. And so we get that t is approximately 7.8125. So from when the rocket launched, at 0 feet it was 0 seconds. And then at 0 feet again, so when it hit the ground, it had taken approximately 7.8125 seconds. Part B. Let h equal 0 in the equation and solve for t. Oh, we've already done that. That was I. Sorry, I read the wrong thing. B says, how many seconds will it take for the rocket to return to the ground? And so out of these two options, how many seconds? Well, it would take 7.8125 seconds, so approximately 7.8 seconds for it to return to the ground. And that concludes lesson 8.5.